So in the last video, we were talking about the vending machine and how inputting a specific code should only give you one product. And if you put in the same code but different products, that means that your machine is broken and is not functioning properly. So if we are looking to determine if a relation is a function, we are going to focus on the x coordinate when given a relation. If the set of ordered pairs has different x coordinates, this is a function. If the set of ordered pairs has the same x coordinates, then that means that this is not a function. The y coordinate has no bearing in determining the function. Basically, if we are trying to determine if it is a function or not, we are only looking at the x values, not the y values. So here we have in example 3, it says, is this a relation? Well, based on the definition, a relation is simply a set of ordered pairs. And it looks like that's exactly what we have. So yes, this is a function. I'm sorry, this is a relation. Now we want to know, is it a function? So we're going to look at our x coordinates. The x coordinates are 0, 1, 2, 3, 4, 5. Are they all different? Yes. So because they are all different, that means that this is a function. So it is a relation and also a function. Example 4 says, is this a function? Your hint is to look at the x coordinates. -1, 1, 2, 0, 0, -2. Are they all different? No. So this is not a function because we have the value 0, which is an input, but it has two different outputs. Now it's kind of like if we think about that vending machine. I put in code 0, I get out a -8. I go back, I put 0 again, but this time I get out a 5. So something is broken here because I have the same input, but I'm getting two different outputs. So this is not a function. But is it a relation? Well, if we look at it, it is a set of ordered pairs. So yeah, it's still a relation, but it is not a function. Another representation that we can look at to determine if something is a function is a set of ordered is a mapping. In a mapping, you have input values being mapped to output values. If you had to take a guess, which of these do you think represents a function? Circle 1 or circle 2? If you said choice 1, good job. We look at the values on the left, which are input, and we see that each one of them has one arrow going to the output values for choice 1. Now, if we look at choice 2, you'll notice that the -1 is going to two different outputs. So that means if I put in -1, there's a chance that I'll get out a 3 or a -2, which means that this function does not work because one input should only give me one output. Try it again. Take a look at example 6. Which do you think is a function, A or B? Hopefully you said option B. Here again, we are looking at the x values. Again, it's not labeled x and y, but we talked about the vocabulary. X means the domain, range is the y, and so each domain should only have one arrow. And if we look at example or option B, each of those values, A, B, and C, only have one arrow. It does not matter that they all go to the value 2. What matters is that they each have one arrow. And if we look at A, we'll see that if I put in the code 2, there's 3 different possibilities, which means that that's not going to be a function. The last representation is going to be from a graph. From the graph, we do something called the vertical line test, is where we draw a vertical line through its graph and we want it to pass through only one point. Sometimes we call this a pencil test, where you will move your pencil from left to right to see if it crosses more than one point. Here's what that looks like. Here we have a graph. We will take our pencil. Starting on the left, we will move it to the right, and we will check. If I stop here, notice that I am only intersecting the graph once. If I keep moving, still only intersecting the graph once, which means, yes, this is a function. Here we are with our second graph. We do the same thing. We begin from left to right. We start out, we are intersecting once. We keep going, we intersect